Hello, Science 110 students. I woofed in for you last week mineral review questions and asked you to download them so that you could work on them and start with the review. I am going to go ahead and go over those questions with you right now. So I put this PowerPoint together quickly this morning so that you would be able to see it and we can go over some of the highlights. The first question was, what is the name of the most common carbonate mineral and what is its formula? Well, you can really eliminate this by looking at the fact that I only taught you two formulas. One of the, you know what the symbol for carbon is, and so you can work your way through figuring that out, but let's see if you remember. It's calcite, and I put a picture of calcite, and its formula is CaCO3, calcium carbonate. And you can remember, I hope, that the mineral group to which calcite belongs, we say that it is a carbonate mineral, but all carbonate minerals belong to that big mineral group that we can say non-silicates. Now we have to distinguish between the terms silicon and silicate. Silicon is a chemical element that has a symbol Si, and you will find silicon in the formula for every silicate mineral, like olivine, hornblende, pyroxene, biotite mica, muscovite, any of these. All right, we say that these minerals are silicates. That means that these silicates have in them as their building block the silicon oxygen tetrahedron. But let's assume that the question asks you to name two minerals that you would find in every silicate mineral. It would have to be silicon and oxygen, because the building block is a silicon oxygen tetrahedron, okay? Then it says name two most abundant silicate minerals in order of decrease in abundance. Start with the one that there's more of, and then name the next one. I'm going to show you the pictures, and I think you probably can identify them from these pictures. All right, that's the most abundant. And that's the second most abundant. The most abundant is feldspar. And the second most abundant is quartz. All right, what determines the shape of minerals? Now, you've looked at some pictures for minerals. Some of you have seen mineral crystals, and so you know that they don't all have the same shape. So obviously something must account for that, and it has to do with the internal crystalline structure. Fancy way of saying it has to do with the way the atoms are arranged, or the arrangement of the atoms, okay? A mineral's toughness or resistance to breaking or deforming, what does that refer to? That's tenacity. When I talked to you about that on the lecture on minerals and their properties, some of the things that had to do with tenacity, we could say that it was elastic. If you take elastic, stretch it, let it go, it's going to get back to its original shape. All right, some of them are malleable, which means that you can hammer it into flat sheets or stretch it into thin wires. And an example of that would be copper, because we have copper sheets and we have copper wire. All right, what chemical test is used for the identification of calcite? And describe what happens. The key word to keep in mind here is that we're calling it a chemical test. And so if it's a chemical test, that means that you're going to add something to it. And this stuff that you add to it is going to help you to determine if it's calcite. And we can add a drop of vinegar or dilute hydrochloric acid. Don't just say or acid, because it won't work for every acid that you put on there. Vinegar or dilute hydrochloric acid. And if it contains calcite, it will effervesce or it will bubble carbon dioxide. Now, you know that we also talked about another property of calcite that is an optical property, has nothing to do with the chemicals, and that's double refraction, which means that if you put it on a sheet of paper and there are letters under there, the letters are going to be double. But don't get that optical property confused with the chemical test, where you have to add something to it and watch the reaction. All right, minerals that make up the Earth's crust are called. Now, here's what we know. Minerals are the building blocks of rocks. And rocks make up a lot of the crust of the Earth. And so if minerals are the building blocks of rocks, then those minerals that make up the Earth's crust would have to be called rock-forming minerals. Examples of these rock-forming minerals would be quartz and feldspar. If you can recognize granite, you are able to tell some of the feldspar in it, and you can tell quartz. And there are examples of things like muscovite mica, biotite mica, that hornblende that may be in other type rocks too, but they are rock-forming minerals. Now, of the 8 elements that make up the vast majority of rock-forming minerals, which 2 are the most abundant? Keep this in mind. The 2 most abundant minerals on Earth are the silicate minerals. All silicate minerals have silicon and oxygen in them. They all have as their building block the silicon-oxygen tetrahedron. So the elements that would be the most abundant of all the 8 elements would have to be silicon and oxygen. You get that? And I know you know what this is. 1, 2, 3, 4, something around one single thing. So this is the silicon oxygen tetrahedron. Tetra meaning 4. So there are 4 oxygen atoms around that silicon. So that's the silicon oxygen tetrahedron, which again we know is the building block of all silicate minerals. Now, the mineral group to which augite, pyroxene, and quartz belong, when you look in your textbook and within chapter 2, and you start reading about augite, it will say it belongs to a group called pyroxene. And then I have quartz, so you may not have heard of augite or pyroxene before today. But you've heard of quartz, and you know the group to which quartz belongs. You know, well, I'm sorry. You know that quartz belongs to a group of minerals called the silicates. And so if it belongs to a group of minerals called silicates, then pyroxene belongs to that same group, because I asked what group. Limonite and magnetite are oxides. Limonite, magnetite, hematite, these 3 are examples of oxides. So they are not silicate minerals. All right, two properties that refer to the way a mineral breaks. One of them is cleavage, the other fractured. You might see written in your textbook something sort of like this. Cleavage, the mineral breaks along where the bonds are the weakest. And if the bonds are of equal strength when the mineral breaks, we say that it is fractured. All right, what are two groups of non-silicate minerals? We're thinking about those minerals that do not have any silicon or oxygen in them. And then it says name a mineral in each group. There are more than two groups of silicate minerals in our text, and you saw more than two on the lecture that I gave. So I put a whole list on here, because if you were answering the question, or if you've already done it, you probably picked two, and your classmate may have picked another two. Now, we talked about native elements, and the native element that your textbook referred you to was sulfur. It doesn't matter whether you say sulfur or diamond or corundum. It's native because it's not combined with any other element. All right, carbonate, that's the other group, with calcite, the one whose formula we are familiar with. Oxides, hematite, limonite, magnetite. Sulfide is galena, which is a lead, it's a lead ore, and it is PBS is its formula, lead sulfide. And then we have sulfate, which is gypsum, and halide, table salt, sodium chloride. All right, two things all minerals have in common, and that has to do with the criteria for something being a mineral, and I just listed all of them. They're all solids, naturally occurring, inorganic. They were never alive or part of something that was alive. They have an internal crystalline structure, definite arrangement of atoms, and they have a definite chemical composition that can be represented by a chemical formula. Look, you had to remember the formula for quartz, SiO2. Its combination is silicon and oxygen. And then we have calcite, which is calcium carbonate. It has in it calcium, carbon, and oxygen. And so these things have a definite chemical composition and therefore chemical formula. That's why the formula for calcite is not the same as the formula for quartz. And then I showed you one day Mohs scale of hardness, which lists the minerals from 1 to 10, from the softest mineral to the hardest. And this says to name minerals 1, 2, 3, 9, and 10. Well, if you have Mohs scale of hardness, here it is. This has them all listed. And something that you should remember is that talc, being the softest, can be scratched by every one of these minerals below it. Talc can't scratch any of these. All right, calcite can scratch gypsum and talc. If you decide to rub a piece of corundum against topaz, the topaz will be scratched because corundum is harder. Okay, that's it for today. Have a good afternoon.